Previously on Homegrown, we met with Dr. Zimmerman and a few others to get a better glimpse of what C-Lock Incorporated is, how they got started, and why what they're doing is so important to the agriculture industry.
So I thought, what we really need is a standardized system that people can use to measure accurately all over the world and compare results. We can help farmers make money by knowing what's going on, and we can help them reduce their environmental footprint, but they got to be able to measure it. So I left the School of Mines and started the company to build systems that could help people monitor trace gases from ruminants.
How cool is it that a global leader houses all of their production right here in South Dakota? This week, we'll take a closer look at the manufacturing side of C-Lock Incorporated when they take us on an exclusive tour of their Rapid City facility.
This is our Smart Feed Pro. Smart Feed Pro takes our standard Smart Feed bin, which is a typical feed intake system. So how those systems work are by basically capturing all of the animal behavior and feeding behavior of these animals when they go to eat. So as they approach the system, this RFID reader will actually scan their ID. We have load cells underneath this bin, which then capture a weight, and we record and monitor with a high degree of accuracy exactly what each individual animal is consuming. As you know, we couple that with our Smart Scale, which is a scale that we provide to producers that you can place in front of the water. So every time these cattle go to water 6 to 8 times a day, you're getting body weights. You can correlate average daily gain and feed intake to get you a feed conversion ratio. And as we know, making a 25% difference in that area has 4 times the effect even than increasing average daily gain by 25%.
So my official title is Chief Technical Officer.
Okay.
And I've been with C-Lock since the beginning.
Okay.
Scott, Pat, and then one of our lead engineer, Mike, started the company back in 2009.
Okay.
Yep.
One of the things you guys do here at C-Lock is you have to make some of your own components. And some of that is the 3D printing.
Yep.
So what are we doing here? This is interesting.
So here at C-Lock, we have about 60 parts that we design specifically for our machines.
All right.
So we're not at the volume where we can do injection molding and make it cost effective.
Yep.
So we use end-use parts that are 3D printed.
Awesome.
And that also allows us the flexibility to modify the parts as needed. If we have a component change or want to change a fitment, we can just edit it quick on a computer and then
You can just do it right here. You don't have to send it to China, a whole bunch of things. You just do it. And so as this thing's going, and for those that haven't seen a 3D printer, we've got this spool of plastic basically coming up through here, and as that thing's going around, it's melting it and putting it onto a certain...
Yep.
What's this thing? That's kind of cool.
That's another printer. That one is a larger machine, so I can do more parts at once.
Okay.
What's kind of nice about the larger machines is I can set it up to do like 2 weeks worth of product before I go home.
Really?
And then when I come in the morning, they're ready to go.
It can work all night and nobody's here.
Yep.
Lights are off.
Yep,
So is this is something that was printed? Is that, I'm assuming?
That's the largest part we print here in-house, and those take about 13 hours to do.
Okay.
And that is a part where the fan for the green feed sits inside of.
So it's a housing for a fan.
Yep.
Okay.
It's at the top of the green feed that you guys were just looking at.
Yep. Oh, this must be that.
Yeah, we print these fans. I try and do 2 a day, every day during the week. And then I use the other machines to do smaller parts, like that mounts infrared sensor, so we can tell where the cow's head is.
Okay.
And then these get sent to be assembled. There's another part that goes on the end. And then they get painted.
I know nothing about 3D printing. Are these just a certain type of plastic, different types of plastic? What?
We use mostly this gray. It's called PETG, and it's closely related to high-density polyethylene.
Okay.
But it's engineered for easy printing, and it's UV stable.
This is some of the data collection here and the quality control.
That is
green
correct.
feed, is that right?
Yes.
All right, so show us what we got going on here.
Perfect. Well, one of the things we do here at QC is run our CO2.
Okay.
So we have a scale.
All right.
Zeroes out for us. We can go ahead verify, see what we have. Normally we write those down just to verify, once again, that it's kind of staying within a certain range. And then we weigh the whole setup to kind of give an idea how much CO2 we have in our whole system right now.
Okay, so we've got the number, we've got the weight of the CO2 here.
That's correct. And with that, we just place it in the system. And so what's now happening is that it's taking that CO2, it's going up, and kind of where you see the brass fitting is taking the sample, going back down, and measuring what we're outputting.
So that's giving us data right now.
That's correct.
From what's going out.
And the customers also have the option of using the app, and you can kind of see a slight rise in the CO2, and hopefully we can get the customer the best numbers we can. Yep, on this one we can kind of see the live output on our app. And then after that, we kind of take that information, it uploads to our server. And so we always measure it afterwards. Yep, measure it again. But we can also verify that nothing has changed.
Good, yep.
Yep. Place in our tank. We write down those numbers. And once again, this is kind of a repetitive process. But as we kind of go through, we're also verifying that our CO2 recovery, which we send with the customers, is also working properly and there's no leaks and other issues that may arise going through it. Yep, yeah, here in QC we kind of go through and verify, everything has been done correctly, all the wiring's correct, physical, normal stuff you'd find in a QC setting, but we also verify that those sensors are working as intended.
Right.
And so we get the fun job of troubleshooting and making sure if it's not working correctly,
what's going on.
Yeah.
Yes. It's pretty tough to measure things out there. There's a lot of miles in between things. And so I'm also assuming that as this data is collected, it's sent to somebody's phone or you can see it all.
All of our data is transferred via Wi-Fi or cellular data service. Okay. And so it keeps our producers up to date on what's going on with their system. Our customers own their data. There's some other folks in the business out there that utilize the data for other back-end products and services, whereas when these clients work with us, this data is very valuable. And they're the ones financing this, so they should own it in our eyes.
All right, we're here with Bear. Bear, tell us what you do here at C-Lock.
So here at C-Lock, I wear quite a few hats. My primary job is automation and programming, so anything that's CNC related, I do all the programming, I write all the code, I design all the fixtures and all the setups, and then I write the processes from start to finish for all the in-house manufacturing. I also double as the facilities manager, so I handle all the contracting, all the electrical upgrades, and I'm also the safety officer for C-Lock.
So you're not very busy.
Not in the slightest.
Well, I'm just looking around here, all kinds of things that I'm assuming you've made and some really cool machines here. Can we run some of these things and see how they work? And so this is a 5-axis machine?
5-axis.
Explain that to the layperson like me that doesn't know what that means.
So in normal machining operations, you only work in 3 axes, so it's going to be an X, a Y, and a Z.
Okay.
A 5-axis, depending on which type you add, adds 2 extra rotaries to there. And what it does is it takes a part that you only have access to either from the top or the sides, and you can rotate and position your work. So normal other machining operations where you would take a part, you would do one operation, flip your part, re-indicate it, run another operation, then flip your part, and do a finishing operation. I can do that all in one setup.
And we got a whole bunch of fluid there that's basically just getting shot onto there, just basically to keep that cool, as well as flush away any of the material that's being removed. Is that right?
That is pretty much it. It just offers a sense of cooling so you don't get chip weldment to your cutting edge, and at the same time, it also helps remove materials that wash chips off of there because you don't want to machine over material that's already been machined.
Sure. Is this fluid then all recycled?
That does. It just dumps out. It goes into a chip tray right there that catches any plastic or aluminum.
Oh, sure.
After it makes it through the machine, I can siphon it off, and then I have a chip conveyor at the bottom of the machine.
And I like the sign in there.
Another special touch.
Well,
it's funny when they give you a vinyl machine at your desk, you can make all sorts of things like no fish allowed in machine. These are the drive mechanisms that help drive the hopper for our green feed products, but this one is particular to our green feed dual hoppers.
Very interesting, very cool.
This machine has attachments, so these are rotaries and they're axial, so you can have a R, which is a radial, and then you can have an A, which is an axial. And that just means whether it's going to be 90 degrees to the turret or sticking straight out from the turret. Okay. And what this allows is kind of like how a fifth axis does, is I can take a complicated part and I can do it all in one
Hit it
setup.
from two sides. We're going to start with this hex bar, and we're going to come out, put a hole in it, very precise doming on that end. So what is this?
So on our trailers that we build for the units to go out into the field, we put jacks on the corner, so wherever a rancher or research development's doing like that, wherever they place this, they can put these 4 corner jacks down. So instead of having a hand crank, we actually pull the gears completely out of there, and we replace them with this so they can have an impact socket. So it's just
Put that on there and
Yep, just real quick.
So how many different parts do you machine here?
Probably somewhere maybe in the 100 or so different parts that go through there. So this is the cool part right here. So what's happening is I have a code on there that's syncing the spindles together. So now the sub spindle is going to come in. They're going to sync, lock together. The main spindle is going to let go, and it's going to pull the part out and then reposition itself back here for the tool to come in.
Do the other end.
We'll do the opposite end.
So we did all of this, drilled that hole, machined this all down, got it accurate within a couple thousandths.
Exactly.
Exactly. And then it's come out, and then we're going to do that end.
Correct. So our stainless that comes in is just your standard 304 series stainless. There's nothing special about it. And so what we do is so we have this special tool right here that I made this. This is designed specifically. So what it does,
Gives a little bit.
so what it does is it'll come, it'll press, and it'll travel another 200 thou into it to give it the proper pressure, and that'll put the perfect scratch into it. So pretty much anytime this machine's not cutting plastic, it's just making pallets and pallets of stainless ready for our fiber laser to cut. This is just one special tool. It doesn't live with the machine. It only goes on for this one particular operation. But everything else that you see on the back rail right there, those are all the tools that we use for just everyday manufacturing and all of our plastics.
So one of the things I noticed in here from being an old shop teacher, you know, in our high school welding shop, everything was dirty. When you walked out there, you were just getting dirty. And out here, that is not the case. I mean, that must be something that you guys really take pride in, and you must be personally involved in a lot of that.
I do. It's housekeeping's kind of a big thing. It's one of my weekly checklists that we walk through. We try to make it as simple on everybody as it is. If there's something way that we can provide, like a dust collector, any type of tooling, something that just makes everybody's life easier, that kind of helps with just keeping your workspace tidy and neat, and then also in our common spaces too, is also leave it in better shape than where you found it at.
This is a 1500 watt laser. We can cut pretty much any shape you can imagine with the laser. You can dream it up on the computer, turn it into a 2D rendering. This can cut it out.
Yeah.
This is cutting basically with pure light. The laser itself is just the little box right there behind this cart. That little box right there is the laser. That's just the cooler to keep it chilled. Your light is generated all inside that box. So most parts from there come over to our brake press. So all of these are examples of something the laser would have cut out.
Right.
You want a hole, you want a keyhole for a feature.
So we started, we actually saw them sand these holes or sand the pattern in there.
Yep.
So that whole big sheet came over here, lasered out, so now they all come over here flat and cut and ready to go.
Yep.
And we stick them in these things, and what do these monsters do?
So basically, it's a 110-ton brake press. So I can put 110 tons worth of force on something.
So then we take something like this, and we bend it up.
You know, my drawing tells me which side to hit from. I don't have to measure anything. These fingers right here are my bump stops. So if I want to bend this piece 90 like it is, here's a finished piece. All I gotta do is hit those stops. And there's your 90.
There we go. Went from that to that. That's simple.
Yeah.
Cool.
So this would be a good example of something that he's got his entire stainless kit here. This gets assembled into a bin. These get bent together on these joints you can see here, and he would TIG weld the corners here and clean them up nicely so that it doesn't even look like it was welded. And now that's ready for assembly on the other side.
Sure.
That's our most of our stainless gets TIG welded. Most of our mild steel items go through a MIG weld operation. You can see Cy right now, he's got his 4 pallets of parts. He is making his sides. We do also have a wet paint booth. We do some plastic stuff. So everything that's mild steel, we try to powder coat if it can fit in our oven and in our powder coating booth. Right. Our powder coat process, there's a primer coat, then there's a top coat that goes on top of that. Gets put in the oven twice and then cured. And once it's cooled, it's cured to service and you can use it. That's the great part about powder coating. As soon as it's cool, you can touch it, you can handle it, you can do whatever you want with it.
When you spray that powder on there, it's like flour. You
Yeah,
wipe
it's like
it right
flour.
off.
Yep.
And then you bake it.
Yep, the only reason that powder is sticking to that part is electricity.
Right.
So the guns have electrodes on the end of them. They charge it. The cart is grounded, and then it attaches to that steel per that static electricity, basically. And when it goes into the oven, it goes through a chemical process, bakes off, and bonds to the steel. We do have a few plastic parts we can't put in a 400-degree oven, obviously. So they just get sanded and get a quick wet primer.
Yeah, and these were, we were watching those get 3D printed.
Yep.
So then that'll all look.
And you'll see that on that stack on the back of the green feed that goes the highest part of that green feed. That's where all this ends up.
Sure.
So he'll give it a nice scuff, get them roughed up to where
Paint stick.
paint has an anchor profile, and away you go.
Cool.
So we have Smart Feed and Smart Feed Pro. The Pro difference is the gate right here.
Right.
That allows the animal to either feed or not to feed.
Right. So
they use the RFID tag. It'll open up the gate and they can go right through. It does have a training mode in it. You place it on and it just allows the door to move freely.
okay.
But in normal mode, it'll actually lock and not allow the animal to go through.
All right.
Unless the tag comes through that allows it. And it measures, lets them know what animals are visiting, how many times, and how much they are consuming. And then once their time is up, it'll actually
Once they've eaten, because this is all on a scale.
That is correct.
So once they've eaten enough,
it'll go up, kick them
just
out.
pushes their head up. They can't get back in there.
That is correct.
So then we're not only measuring precisely what they consume, we're also controlling that amount so
That's
that we can
correct.
do different experiments or whatever.
Controlling which animal, what amount, whatever visits. There's a bunch of settings they can kind of mess with.
Sure.
And get whatever specifics the customer wants.
Yeah.
And so, yeah, it's a very simple concept, but obviously there's a lot that goes in here, a lot of electronics, moving parts. But going through in QC, similar thing is what we do on the other side. We check the function, the fit, form, how it looks and everything. And this is an example of a modem in one of these units.
Okay.
There's another component in there that's for Bluetooth.
Okay.
And that is what kind of connects
Bluetooth to your phone.
Yes, but the modem allows the data to then be sent to our servers, so where they look at the data and actually make sense of it.
So that's where the data is coming back to CLOC.
That is correct.
And the experts are actually taking that data and putting it into some usable forms to help.
Yes, yeah. With my eyes, compared to what we have in shop versus out of shop, it's a mess out there, and they're able to get useful information out of that.
Man, the manufacturing that is done here is impeccable. It really is. And you can't say that about everything. These things are wonderful. I mean, they really are.
We had a Japanese scientist who works for a company that had 30,000 employees, and he'd been through a lot of their manufacturing plants, and he said this was the best operated manufacturing plant he'd ever seen.
That's amazing.
That is amazing. I was amazed.
Yeah. And that's a lot of kudos to him, right?
And everyone. Everyone. So a lot of these people here are Mines graduates.
Yeah.
We've got several, over the years, we've had several veterans. There's a veterans program. I'm really proud of how we're planting the seeds of innovation, and you know, these people have kids that go to school and play on the sports teams and don't get in trouble, and you know, it's really nice to stimulate that kind of really positive energy in a community.
Taylor Rudd.